Okay, now about CCNA 3, it's all about enterprise networking, security, and automation. So far, we have looked at introduction to networks, CCNA 1. CCNA 2 was about routing, switching, routing, and wireless essential, CCNA 2. And now the last one is enterprise networking, security, and automation. So this combined together now will form the entire CCNA, the entire CCNA. Okay, that you guys need to go through. Okay, so within the CCNA 3, will just be, improving from where we left. That is, what I meant is will actually be, it's just a continuation of CCNA 2. But now we'll be introducing more protocols here, and also we'll be looking at the security aspect of our network. That's very, very key. Now, last time, remember, we did a configuration CS using static routing, static route. And all the networks or the devices were able to communicate to each other through static. But static is limited in that the more the complex your network is, okay, the higher the disadvantageous, it becomes in terms of, the reachability of other devices. Let's talk of corporate or regional kind of network. You cannot rely on static routing, but we need both. We need both static routing and dynamic routing, because with static routing, mostly you'll find that it will be required when you are mapping, okay, a given network, and more so the public network from the private network or from the internal network. So you want to link with the service provider. So basically, with that kind of setup, mostly you'll require, the static route just to link it up. But now internally, you cannot be configuring your network with static. That is within your domain, with all your branches countrywide. So you cannot be using static routing with all your branches countrywide. That's why we're now bringing in dynamic routing. So with this dynamic routing, we have interior gateway routing protocols and exterior gateway routing protocols. And within the interior gateway routing protocols, now we'll be talking of the protocols like, the OSPF being used, okay? We have the likes of ERGRP, Enhanced Interior Gateway Routing Protocols, being used. We have the likes of RIP, Routing Information Protocol, version 1 and version 2, and such. ISIS, all this, okay, but ISIS is more on the ISP end, okay? Even the ERGRP, we have the one for IPv4 and the one for IPv6. But the curriculum covers the OSPF, one of the dynamic routing protocols known as the OSPF, which is again the interior gateway routing protocols. Meaning what? When it comes to our domain, we can actually use this protocol to advertise our network, and that's now what we'll be discussing. Here. So let's see what it entails. This single area OSPF, and also its configurations. Okay, so there is a lot that we're going to look at, or we're going to discuss here as we move on, including the router ID. So you must have the router ID coming in. what is the essence or the importance of having the router ID, especially when configuring the OSPF? When it comes to point OSPF, okay, what do we need to have here? Okay, how about multi-access, OSPF? Okay, and what is this multi-access OSPF? So we have different types of OSPF, the likes of point-to-point OSPF, the likes of multi-access or OSPF as well, including the remember last time we did router default what setting up a default route. Okay, yes, we can still set up that default route with our OSPF, but now the beauty of this one, remember the last time we did that one, but now you don't have to configure this in each and every router. Instead, it can be propagated, and that's what we will be doing, and see the difference now between the two when you have now the static and the dynamic now coming in. Now, yes, you might be within the same area ID or different area ID. So if you are within the same area ID, basically means you are within the same domain, So, and in this case, if you look at now the diagram that we have, R1, R2, R3, they are all under the same area, except the public network, the internet. Okay, the internet, which is not part of us. That's now the ISP. But the rest now belong to the same area, or we're using the same area ID, including all the interfaces of each and every router that we have here. Okay, so that's the most important bit, except the loopback on R2, the loopback one on R2, because now it's connecting the internet. So it's not our own, no? So we might not have the control of it. Now that's not the ISP. Okay, so in that case, that ISP router is our gateway to the internet of the routing domain. For us to get all those internet services, then we are relying on that particular gateway, okay, to have all this. So if you want to set the OSPF, or you want to configure the OSPF, it's very simple. Yes, you simply need to enable that OSPF and MOSO version 2, okay? For the case of IP version 4, because also we have the same for IPv6, that is OSPF v3 is meant for IPv6, but version 2 is just for the IP version 4. So we just need to enable this, okay, router OSPF, including the process ID, So we just need to enable the process ID on a global mode, So what is this process ID? Because this is actually what will be, configuring. So it's just a value representing a number between 1 all the way to 65,535, okay, which you can select from. So you have that range. So you can have any number in between that you can have. And this process ID is locally significant, okay? And in that case, they do recommend that if you can have, the same process ID on all your OSPF router, that's okay. But still you can have different OSPF, like, 10, like 20, like 30 in each and every router, okay? Because that's still the range. But sometimes they do encourage if you can just maintain the same in all, okay, the routers are that you are trying to set up. So when you do router OSPF, then with the process ID like 10, okay, then enter, you will see the mode will be changing to config router. So meaning you are in a different mode. Then when you have the question mark, you'll find that now there are other parameters that you can set, including the area. That again we'll be discussing more as we move on. Okay, you can adjust the cost because OSPF ideally depend on the cost as its bandwidth. Okay, it relies on the cost. Just like we talked over the static routing, which basically relies mostly on the number of devices that you have set up, the one that you have configured. So how far are you from the source? 2 routers away, 3 routers away, and that's why if you look at the static routing AD, administrative distance, you find that by default, it is 1 stroke, something. Okay, so it will just be counting the number of routers that you have there. So, but for the case of the OSPF, it will rely on the cost of the the interfaces that you have set up. So we have those default, which already has been set, but still you can go ahead and do some adjustment or modifications on this. Okay, default information, is another command that we have. The distance, the exit, see, all this are some of the major one. So mostly we'll be looking at the default information, the area, the network itself, the passive interface, the router ID. You can even do redistribution, okay, if the need be, of the same router ID that we have configured, including those, what do you call it, the default route that has been set. So this router ID basically is just a 32-bit value that you can set, and you can try to be unique as much as possible. For example, if it is router 1, you can have it as 1.1.1.1, 4 of them, 1, 1, 1, 1. If it is router 2, 2.2.2.2, 3, the same thing. You just want to make it, a 32-bit, unless you have been given another IP address that you can use as your router ID. So it's being used to uniquely identify an OSPF router, and all OSPF packets include this particular router ID from the originating router. Okay, so again, something to note that OSPF also supports the use of packets. We have 5 types of packets. Okay, the neighbor, the LO packet, and some of those packets that we have. The reply packet, and the acknowledgement packets are some of the major packets, because when we will be communicating, the packets are the ones that will be sent out to these particular devices. Okay, there. So there, every router requires a router ID to participate in an OSPF domain. As long as you have been configured with an OSPF, then you must have, the router ID, because you might be having several of those, routers within the network. So how do you uniquely identify each of these? Through their router ID. And it is you who can set this router ID manually, or sometimes you'll find that it can be done, automatically by the router, meaning it will actually assign a number, a given IP address for you if you don't, set it manually. So this router ID is being used, by these OSPF-enabled routers to perform the following. Number 1, to participate in synchronization of the OSPF databases. That is the exchange. So remember, we have the database. We have the database. So with these databases, I want to know your details. You want to know my details. How will I be able to know your details? That's why the likes of the LO packets are very, very important, play a major role. So in that case, during different state, like the exchange state, the initial state, because those are the states that we have, until you get to the full state. Okay. The highest router ID will send their descriptor first, because we want to know on this network who is who. Okay. Especially when it's come to an election process within our devices, we have those election process that normally take place. Okay. You cannot all be, how do you call it? The president or the leader, the group leader for that matter. Only one person can be the group leader. But now there are requirements for you to be a group leader. What is this requirement? Okay. So based on that, that's how we can carry out that election. So the same thing also with our device on the network. So we need to know who is the overall router, who is the supporting, the backup router, then who are the others. So it's like having class rep and assistant class rep. Okay, let's talk of that. Class rep and assistant class rep. So the class rep become the designated router, meaning on behalf of other routers, you're the one communicating to the rest of the network. So meaning all other routers are channeling your request to you. And also in a multi-access network. A multi-access network is a network with more than 3 routers, at least 3 routers. At least 3 routers, not point to point. Point to point is well known. It's me and you and me, we are connected. So if I'm the DR, definitely you are the BDR. If you are the BDR, I'm the DR. That's the point. Okay, that's the point. But now in a multi-access network where there are several routers connected or interconnected, then you must elect one to become the DR. And in that case, you will find that the one with the highest router ID, the one with the highest router ID will be elected to be the what? The DR. So we have talked of router 1 as 1.1.1.1, router 2 as 2.2.2.2, router 3 as 3.3.3.3. So in this case, following the examples that we have stated, which one do you think, in your opinion, will be the DR based on those router IDs that we have mentioned? 1.1.1.1, 2.2.2.2, 3.3.3.3. Based on your opinion, what do you think will be the router ID or the router ID B based on those router IDs that we have mentioned? Because I said the one with the highest become the router ID. Okay, so what do you think will be the router, or rather the one with the, okay, Lonya, 3.3.3.3, correct. Yeah, 3.3.3 will become the one with the, highest router ID, and therefore it will be elected to the what? The DR. Then the second one will be second largest. Second largest will be, so already we have the DR. So who is the deputy? Second largest will be two. Correct. Second largest will be 2. Okay. Then the remaining one, that 1. No, you are not nowhere. You are not DR, you are not BDR. So you are other or others, depending on the number of routers that are there. So among the others, in case of any challenge, among the others, in case the DR is not available, there's a problem with the DR, BDR will be promoted to become the what? DR. Then the remaining one, again we check, okay? For you to be the BDR, because the DR is already there, then we check now which one among the remaining one should become the BDR. Again, we look at the router ID that has been provided there. So that's the point. Okay, and that's how they do communicate. So in that case, we have some order of precedence that again are very, very important. Okay. So we normally check what to be checked first. Because we have talked of the router ID. So what to be checked? So how do you come up there? This. So where the router ID is configured or has been set up, then that's what will be used to identify the one will be becoming the DR and the BDR. So that's the first thing we need to consider. Okay. If the router ID was not used, maybe you did not set the router ID, even though you have the OSPF configured on your network, but the router ID has not been set, then that means it will check the loopback interfaces, more of the virtual interfaces, if at all you have some configured. So with these loopback interfaces, which one has got the highest IP address? The router chooses the highest IPv4 address of any of the configured loopback interfaces. If one is installed, okay. If there's no router ID installed, if there's no loopback interface installed, then definitely, we have those interfaces of the routers. The interfaces of the routers always will be there, okay? Whether you like it or not, because you'll be configuring those interfaces. G000 of R1, G000 of R2, G000 of R3. Of course, they represent different networks. We might have 192.168.1.1 for that first router interface, 192.168.2.1, okay, 192.168.3.1. In that case, it will consider 3.1 automatically. So the active but the highest interface will be selected here. So this is the order. So if step 1 and 2 are not there because they're supposed to be configured anyway, 1 and 2 are supposed to be configured. If 1 and 2 is not there, then definitely it now work with the last one, the physical interfaces. Remember, step 2 is the loopback. Number 2 is the loopback interface, the virtual interfaces. But if not there, then physical interfaces will take over. But again, it will check. Okay, the one with the highest, IP address are there. So that's actually the point. So router ID explicitly configured, yes. Okay, yes, use that as the router ID. No, if no, do you have any loopback interface configured? Yes. If yes, use that as the router ID. No, no loopback interface configured. Then use the highest active configured IPv4 address to set up that. So you can see that's the order of these precedents that they do follow. So there's no way you can miss the router ID. Either way, you cannot miss the router ID. Okay, as long as the OSPF has been used. Now, you can here set a loopback interface on your routers, just like the other interfaces. But remember, these are more virtual, software-based. Okay, they're more virtual. They're not physical. Are there? So you can set this using the IP address and the default, subnet mask. That's how they're being configured. The loopback interfaces. Okay, the default. That's how actually you can set them there, and therefore you'll be having your own loopback interface as they are being set up. So you can see the example that we were giving, like R1 uses the router ID of 111.122.22.23.3 there. For each and every router, you just want to confirm, do you have any router ID set? Issuing show IP protocols, yes, we'll be able to see that one. Even show run, okay, we'll be able to view the results of all this. Okay, that has been set. So we have that router ID being set. Yes, sometimes I don't want to use those default numbers like 1112222. I just want to use the normal IP address also. So you can do a modifications, okay, there. So you just basically just need to remove, you need to remove the previous one that you had set are there. So you can use the command that you can apply is clear, okay, clear IP OSPF process. Okay, reset all OSPF process, yes. Yep. Then upon reload, now it will be able to give you a new one. Okay, it will be able to give you a new one. So you can set, okay. So you can see here they had set the router ID 10.10.11, 10.10.11. But now along the way, you have changed your mind. I just want to have 1.1.1.1. So that way, you can just simply clear the first one. Okay, you clear the first one. So you'll be told here, okay, when you just do router ID 1111 and there's already one existing, you'll be told that reload or use clear IP OSPF process command for this to take effect. So you can have reload command, okay, or clear IP OSPF process. Then it will be able to give you the new one that you have set there. Okay. Now, as we have said, we have different types of networks for the OSPF. For the OSPF, take note of that. OSPF networks. We have point-to-point, okay, and of course the multicast also. So I want us now to look at this, the difference between the point-to-point and OSPF, because this is another common questions that normally being set in the certification exam. Okay. Now, yes, we can advertise the network. We can advertise our networks. So in that case, you can do the network advertisement on a global mode, or simply you can do it on the interface. So it depends. You can advertise your network on a global mode. The command is, will be network. The network that you have. And this time around, there'll be no subnet mask. Instead, it will be what? Wildcard mask. Wildcard mask being used. Then now with the area ID, you must have the area ID. You must have the area ID. So the network address wildcard mask syntax will be used to enable OSPF on interfaces. Okay, that's actually what it will do there. The area and the area ID syntax refer to the OSPF area. So which area are you? Because you see, we might be connected to each other, but you're on a different area, I'm on a different area, and yet we are connected. So I must define your area where you are. Okay, I must define your area where you are, and also I must specify my area, okay, where I'm located. So that's actually the point that we have. So whenever dealing with them, area ID, so you just set the area ID there as per what you have been given, because with the OSPF, there's no shortcut. It has to use the area ID. Area and the area ID will be used here. Okay. Although any area ID can be used, so it's always a good practice to use an area ID of 0. So this become like the backbone area. Okay. 0 is the default number. So it means the rest of the other areas can be attached to this. Okay, can be attached to it. So that's the point. That's the point there. Now, because we are using OSPF, guys, remember, there is no subnet mask that will be set up here. It will be what? How do you call it? It will be a wildcard mask. Wildcard mask is just the opposite of the subnet mask, or the inverse of subnet mask. So within the wildcard mask, you know what a 1 is, what a 0 is. Okay. Now it's now the opposite, the other way around. That's the meaning of the inverse here. Okay. That's the inverse here. So what's a 1 and a 0 in a subnet mask? Okay. So we know very well a 1 and a 0 in subnet mask are there in terms of matching and no matching. Matching and no matching. Now, when it comes to wildcard mask, again, that's what we'll be looking at here. But now, how do you find the wildcard mask? Very, very important. Okay, consider some. I can see there's some mistakes that they have made here, especially the second one. The first one is okay because you just need to subtract your subnet mask 255.255.255.0 from 255.255.255.255. Then you'll be getting 0.0.0.255. Okay. For the case of prefix 26, those are 2 bits. So that's 192. So it's 255.255.255.192. We need to subtract it from 255.255.255.255. What is that? It will be, if you subtract 255 or 192 from 255, what do you get? What do you get? You'll get 63. Okay. So it means your wildcard mask will be 0.0.0.63. Okay. 63 are there. So that's how actually you can set it. So meaning these zeros, the zeros we are referring to, must match with the network. So when coming in, the first 3 zeros is what I'll be looking at. 0, 0, 0. Leave alone 63. 63, when you convert to binary, you get ones and something. Okay. But now the most important bit is this 0, 0, 0, 0. Is it matching the network ID? Okay. So these are matching and not matching. So 0 is a match in wildcard mask. Okay. In subnet mask, 0 is not a match. 1 is a match, and such. So that's actually the point that we have there. So in the first example, the wildcard mask, if you look at this, network 10, 10, 1, 0, then 0, 0, 0, 255, area 0. So remember, this is a network. We are setting up a network, router OSPF10, then network. Then we have 10, 10, 1, 0, then with 0, 0, 0, 255, area 0. The first 3 zeros will confirm, assuming you are receiving a packet, or you have received a packet whose address is 10, 10, 1.5. 10, 10, 1.5. What will happen in this case? So for me, I'll check the first 3 octets, 0, 0, 0. 10 and 10, the first 10 and 10 with the other one, okay. The second 10 and 10 with the other one is okay. The third 1 and 1 is okay. So these are matching because of the 0, 0, 0. But the last one, dot 0, is not a mask because you see, I've talked of 10, 10, 1.5. So it will just ignore that one. As long as the first 3 are matching, then I'll not mind about the third or the last octet, .5. So it means anything which is 10, 10.1.1, correct. 10.10.1.2, correct. 10.10, 1.3, correct. 10.10.1.4, correct. 10.10.1.5, correct. I'm just looking at the first three, 10, 10, and 1 because of 0, 0, 0. That's the matching that we are referring to here. Same applies with 10, 1, 1, 4 and 10, 1, 1, 12. Okay. So that's actually what it will check in terms of the network. Okay. In terms of the network are there. Okay. So that's using, that's using the network command. Okay. Now you can have also what I'm calling code 0. It's no longer the wildcard mask. It's no longer 000,255. 000,255. Instead, it is 0000. So here there's no shortcut. Everything must match from the first octet to the last octet. That's the meaning of 0000. Everything must match. 10, 10, 1, 1. So meaning I'm expecting a packet with the same 10, 10, 1, 1. Okay. So because of 0000 or 10, 1, 1, 5 because of 0000. 10, 1, 1, 14 because of 0000. So here there's no shortcut. Everything must match right from the head to the tail must match. It's like telling someone, these people are coming. These people are coming. Now this concept of code 0, the concept of code 0. This person is coming. Allow me to mute some people for the sake of my ears. Okay. These people are coming, so you are giving condition at the gate, telling the askari at the gate, the person must have everything red, kofia red, top red, longi red, socks red, viatu red. So you can just imagine such. So meaning everything must be red from top to bottom. So allow him in. Allow him in. Everything's red. That's the meaning of 0000, code 0. So in case there's a mismatch kidogo tu, maybe in terms of the viatu, red and white, once, ignore, because we need everything red, red, red. But now, this person with now everything red, but one kiatu is white, now will be accepted in the previous slide, this slide of 10, 10, 1, 0, because of 000255. Meaning, just check the first three, okay, then the last one ignore. So the person with a mixture of red and white will be accepted in the first example. But in the second example here, you cannot be accepted because it has to match throughout. Okay, that's the use of the wildcard mask code 0. Code 0. Okay. Now, the advantage of specifying the interface is that the wildcard mask calculation is not necessary. Okay. Unlike the first one, especially where there is subnetting, because you might have subnetting also on your network. So be ready to calculate the wildcard mask because there's subnettings. But code 0, nothing like that. Okay. And mostly, by the way, this applies to interfaces. The interfaces, the interface IP address, not the network. The first one is okay with the networks because here we are dealing with the network. 1.0 is a network, 4.0 is a network, and 1.12 is a network. Perhaps subnetting was done here. That's why you're getting even 12 for the network because of subnetting. 4 as a network because of subnetting. Okay. So that's fine. That's okay. Okay, but now this one, you don't need data. So it applies mostly for the interfaces are there. So that's now using the network command to configure the OSPF. Network command to configure the OSPF on the global mode. On the global mode. Okay, that's one way. The other way you can actually advertise OSPF is using the IP OSPF command. And mostly this is being required on the interfaces. On the interfaces. Okay, so you can use either the first one or you can use this one here. How do you configure this on the interfaces? Very straightforward. Just go to each and every interface of the router and the area each belongs to. So IP OSPF 10 area 0 must be enabled on a global mode. You must start from there. IP OSPF 10 area 0. So this one is being advertised on a global mode so that when you go to the interfaces, it will be accepted. Then you go to each interface, gigabit Ethernet 001, 001. Then IP OSPF 10 area 0. Okay, for that interface. Then another interface, which is the loopback interface, loopback 0. Then IP OSPF 10 area 0. You see, you're just advertising the network. You are advertising the network using either IP OSPF command or using the network command. So it's upon you to decide which one is which. How do you want to go about this? Through the interfaces or through the global mode? So that's upon you. No one will restrict you, okay? Because the idea is I want to do what? I want to advertise my networks. Now, passive interface. Passive interface, okay? What is the importance of configuring a passive interface? Now, what do you know about our routers? Okay. Now, I'm router 1. This router 1 is connected to a switch. This switch is connected to the PCs. This router 2, this router 3. If you can recall our previous topology, because I'm still having it here, because this is what I'll be using to configure OSPF. If you can recall this topology, this router, okay, we had this as router 1. I think this was router 1, if I'm not wrong. That's what you had set. We had this as router 2. So allow me to rename this. Just more external naming. And this as router 3. Now, if you look at these routers, guys, you'll find that each router is connected to a LAN, meaning it's a switch 1, PC 1. Okay, there's another switch 2, PC 2. Another switch 3, PC 3. Okay. That is how is passive interface coming in. Now, as per the routers, R1, R2, R3, R3, R2, R1, we are communicating as routers. But now, we need to block or suppress the PCs and the switches. Okay? Hearing what we are talking about. Because for us, we are using the same language, OSPF, all of us, R1, R2, R3. Any secret being discussed, R1, R2, R3. But we don't expect now the PCs and the switches in each router, attached to each router, getting all this. So we will be setting the passive interface. Why passive interface? What is the importance of setting the passive interface? Okay, because of those messages that are being sent out, we want to ensure that now our network is free of congestion. So there are 3 ways, okay, it can affect our networks. Sending out unneeded messages on a LAN affect the networks in three ways. One, inefficient use of bandwidth. Anything that is not even necessary is being consumed. I mean, it's consuming our bandwidth. So a valuable bandwidth is consumed transporting unnecessary what? Messages. That's one. Two, our resources. We need to, save our resources that we have. And when talking about resources, in that case, bandwidth is one of it. CPU is another part of it. So all devices on the LAN must process and eventually discard the message, because you see, it's part of it. So it means you are engaging your OSPF. I mean, how do you call it? CPU. Okay, you are engaging the memories with the things that later will be dropped. The things later that will be dropped. Okay, just like, take a good example. During the interviews, you did the interviews before joining this program, and there were requirements. Those requirements is what made you to be here. You are shortlisted. Not all were able to get in. So what do you think? You want to have everyone on board, including those who have met the requirement and those who have not met the requirement, all of them in your interview panel. And you know very well, either way, these people have not met the panel, even though they are part of the panel. So it means they are utilizing your resources. Then you see, at last you are dropping them out at that stage. So you see, that's the point. So therefore, we need shortlisting is very important, because now we are trying to do away with those who have not met the requirements here. Those who have not met the requirements, we're doing away with them. Then remain with the one that, you see, we are trying to utilize the resources that we have. So the same thing with the routers again here. Here, that's what they are doing. Then on the other hand, again, security concern. Okay. Because if OSPF is not properly set, because you can also set those packet updates with the security. So without additional OSPF security, then these particular messages can be intercepted. So meaning only OSPF enabled packets would be allowed within our network. Only OSPF enabled packets will be allowed. Any other packets not allowed. Okay. So that's the point. So intercepting all this is what actually we're trying to avoid using the other packet sniffing software like Wireshark, TCP dump, and the rest. So that's what we are looking at here. So these are the major ways we can actually prevent all these unneeded messages by suppressing this, okay, these particular messages when you have configured the OSPF. And it has to be on the interfaces. Okay, you can see passive interface loopback 0, passive interface G000, passive interface G001. Okay, so passive interface being used here to prevent the transmission of routing messages through a router interface, but still allow that network to be advertised to other routers. So it will not affect the communication within the networks. Meaning PC1 is able to communicate with PC2, that's the point. But any, how do you call it, eavesdropping, more of eavesdropping is what we're trying to prevent here. Okay. So you can confirm this using the show IP protocols to see which are these interfaces that have been set with passive, So loopback is one such as per the example that we have here. So that's the most important bit that is given there. Okay. Now, we have talked about point to point, point to point. Okay. As one type of the OSPF network that we have. So by default, Cisco routers elect a DR and BDR on Ethernet interfaces. Okay. Even if there is only one other device on the link, that's the point. That's the point there. So in that case, always your network type, look at this, your network type will be broadcast. Even though there are two routers, I'm router 1, you are router 2, but still an election is taking place. The DR, BDR is taking place, and such, because of this type of network. Okay, so we need to notice that one. The DR, BDR election process is unnecessary as there can only be two routers on the point-to-point network between R1 and R2. But just check on that, your output. As designated the network type as broadcast, which should not be the case for point-to-point. For point-to-point. I remember this was in the certification, no? I think, which year was it? 2023 or 2021 or 2022 there. Okay. You are being given the exhibit like this. Then you're being told that, so and so as router 1 and router 2. Okay. And that means there is no need. Okay. He or she wanted to disable that election of DR, BDR. She wanted to disable that election of DR, BDR. Then you're being asked what you're supposed to do to disable that, to disable that. It's a very interesting bit. So long as now we understand what you're doing, and if you look at those choices, because always they do have choices anyway. Okay. So you'll find that now, the person needs to change the network type to point-to-point. And how do you change the network type to point-to-point? That's now the big thing are there. Okay. Now, to change the network to point-to-point, this is what you need to do. Interface Gigabit Ethernet 000. Enter. IP OSPF network point-to-point. So you'll find that this is among given in the choices. Okay. There. So when you do so, you'll find that now that the network type has changed to point-to-point, it's no longer broadcast. It's no longer broadcast. Okay? That's the point there we need to consider, as simple as it is, when setting this. Okay? So loopbacks and point-to-point networks. So basically, why loopbacks? You see, apart from the physical interface, G000, G001, you can always have a loopback interface, just to provide additional interfaces for a variety of purposes. By default, loopback, as we have said, will be advertised using a prefix 32, meaning 255, 255, 255, 255, all of it. That's how it will be set. So again, to simulate a real LAN, the loopback interface can be configured as a point-to-point network to advertise the full network as well. And that's what they're trying to explain for you here, guys. So you can do that one. So you can see how that has been set. Become the loopback up there. Okay, we have the multi-access OSPF networks. So basically, this is actually where the election will take place. So expect the network types to be broadcast here, because you have more than one routers, at least, two routers. That's okay. So OSPF will be set. So a multi-access OSPF network is unique in that one router controls the distribution of the link state advertisements. This is another type of packet that we have. Link state advertisements, another type of packet that we have, because this is what will be going round, 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 round. Okay. So with the OSPF designated routers, as you have said, the DR, because all of us, as you have said, you cannot be the class reps, all of us. Imagine where all of you are class reps and, reporting to one person, Kevin, all of you. So anything can happen, yes, I'll report to Kevin because I'm the class rep. Within few minutes, you're reporting to Kevin, the same thing. Within few minutes, another person reporting to Kevin. So you see, at the end of it all, okay, all of us, we have reported the same thing. Okay. So to avoid that kind of confusion there, then we need to know who is the class rep so that at least all of you can be reporting to class rep. So class rep will be able to filter. Oh, already it has been reported, so I have it. Okay. And I've reported it to Kevin. So at least, the DR, the class rep, the president here, is filtering most of those things which are now coming from the others, because now we have DR, PDR, and others. Okay, to ensure that now only one channel of communication is being used. So that's the multi-access here. So the DR is responsible for collecting and distributing this kind of link state messages, okay, that have been sent and received. And how do these DR send out these messages? Through which type of address? Through multicast address. Through multicast address. DR uses the multicast IP4 address 224005. Take note of that, which is meant for all OSPF routers. Okay, that's how I will be distributing the same. Okay, just a minute, guys, a minute. Sorry for that. Let's proceed. Now, so we have agreed, because this is another question normally they do set in the exam, how DR, is communicating. Okay, it uses the multicast IP4 address 224005, which is meant for all OSPF routers. That's how actually it will be communicating with the rest of the routers. Then we have the BDR, a backup, meaning backup designated router. Okay, is also elected in case the DR fails. Okay, at one point, do we elect this BDR to become the DR? If the BDR now fail to listen from you as the DR, the BDR listens passively and maintains that relationship with all other routers. So if the DR stops producing LO packets, okay, then the BDR automatically promotes itself and assumes the role of the DR. Because you are no longer communicating, you're not communicating. So what do you expect? Things will not start because of that. So I'll promote myself as the BDR to DR. Okay, are there. Then we have DR other or others, meaning a router that is neither the DR nor the BDR. You are others. Okay, so others also communicate using a multicast address 224006. Okay, Dear others, use the multicast address 224006, all designated routers, to send OSPF packets to DR and BDR. Okay, others. Okay, others. So take note of that. Only the DR and BDR listening to this, not any other. Okay, 224006. That's the others to DR and BDR. Then DR to all other routers, meaning DR to BDR and others. So from the top, from DR to BDR and others, 224005. From the bottom, DR others to BDR and DR, 224006. Take note of that. You'll get it somewhere if you are preparing to do any certification. Okay. Now, so this is the topology that we have. So you can see in this topology, it's a DR and the BDR. Okay. But now election is being carried out here based on three criteria that we talked about: router ID, loopback, and what? And the physical interface, highest IP address of the physical interface. Okay. But if you look at this one, they have set the what? The router ID. So we can use router 1, 2, and 3. So which one becomes the DR? Yeah, because you can see router 3 become the DR because of the router ID. The highest, everything else, it has to be highest. Router ID, highest. Loopback IP address, highest. Physical active interface IP address, highest. Okay, that's what you just need to consider. In case you have been asked in the exam, those three things. So consider highest to be there, a DR there. I teach as I prepare you for the, just bringing you, up to speed for what also you do expect in the certification exams, which is very, very important as well. So show IP OSPF interfaces just to verify the OSPF router roles. Were you configured to act like a BDR, a DR, or your others? Okay. So if you want to confirm, because these are being set on the interfaces, show IP OSPF interface given Ethernet 000. So you can tell, okay, that router 1 is what? Okay, state, here, other. If you go back here, it is here. Okay, it is other because it has the least router ID. It cannot be BDR. BDR is router 2 and the DR is router 3. So the state here, okay, the state here, you can see. Then we are being told the designated router ID is 33333, that's router 3. Okay, with the interface that, and the backup is router 2. So all the states you'll be able to see by issuing that particular command there. Okay. If you check the other router, this is now router 2, you'll find that the state of router 2 is BDR. Okay, but still you're being told DR is 333 and BDR is 222. Okay. If we check the last router, is the DR. Okay, it's the DR, designated router ID 333. Okay, backup is 2222 there being given. So it's just a matter of just verifying this. Okay. Now, with OSPF, we have what are calling adjacencies. At what point do we form adjacencies? Remember, we talked of neighbors. We are neighbor. R1 connected to R2, they are neighbors. Okay. R2 connected to R3, they are neighbors. So for R1, R1 is also the neighbor of R3. Because for you to get R3, there's R2 in between. So there's no way you are neighbors. I'm only neighbor to R2 that way. And R3 is neighbor to R2. So in that case, there are these particular states which are very, very important. After you have set up the OSPF, verify the OSPF adjacencies. Show IP OSPF neighbor command will be required here because now you'll be able to see the kind of output. So there are only about 1, 2, 3, 4 states that you can get. The state that you can get is full stroke DR other. What's the meaning of this? It's one state. So these are a DR or BDR. Okay. I know this sometimes do confuse the students. Full stroke DR other. Okay. So meaning what? A DR or BDR router that is fully adjacent with non-DR or BDR. That's the meaning of this. These two neighbors can exchange hello packets, updates packets, query packets, reply packets, and acknowledgement. So all the packets can be exchanged. Okay, because we usually have 5 packets: hello, updates, query, replies, and acknowledgement. When you get the state full DR, the router is fully adjacent with the indicated DR neighbor. These two neighbors can exchange hello packets, updates, queries, replies, and acknowledgement. When you get full BDR, what's all this? The router is fully adjacent with the what? With the indicated BDR. Okay, so these two neighbors can exchange hello packets, updates, queries, replies, and acknowledgement. When you get two-way, so these are possibilities that you can have. Two-way stroke DR other. So the non-DR or BDR router has a neighbor relationship with the another non-DR or BDR. These two exchange hello packets only. Okay. So the remote state for the OSPF is usually full. So full, can see full. Okay. So what is the meaning of the two-way then? If a router is stuck in another state, okay, it is an indication that there are problems in forming the adjacencies. The only exception to this is the two-way state, which is normal in a multi-access broadcast network. Okay. So I hope you have seen, with those DSTV things, sometimes you just do the normal switch and, direct. You just get to watch what you want to watch. But at one point, you might do then update from nowhere coming in, meaning a new thing was added, okay, to it. And therefore, there's some adjustment that is taking place there. So whenever verifying this, we have the state full DR other or full DR. So those states that you have seen there are what you'll be getting there. Now with election, default DR/BDR election process, you want to do an election, okay, to elect will be the DR. So as we have said, the order, okay, remember it's default, okay, default means what? Okay, it means maybe you did not consider configuring the router ID there. So what happens with that one? So in sequential order, the routers in the network elect the router with the highest interface priority, because you can set the priority, by the way. The priority number can be set on the interfaces. Apart from the router ID that you have talked about, you can also set the priority number. That one will be there by default, by the way. Okay. So the router with the second highest become the BDR. And what are these priority values that you have? A number between 0 to 255. So when you have been set to 0, you cannot be elected as BR nor BDR. Okay. When you have been set to 255, then you are the highest. You are always the highest. You remain the DR forever, unless someone want to force it by modifying the number. But the default priority of multicast broadcast is 1 as per the output up here. You always get this one. Without configuring it, it will always be there with the output. This 1 1 will always be there. So you can have the default, all of us, router 1, default 1, router default 1, router 3, default 1. Okay, that's why they're talking of default DR, BDR election. Now, if the interface priorities are equal, then the router with the highest router ID is elected. Okay. So the router with the second highest is the BDR there. The election process takes place when the first router with an OSPF enabled interface is active on the network, meaning you are live, you are up. Okay. If the rest have not yet finished booting up, okay, it is possible that a router with a lower router ID becomes the DR. Because you see, yes, I have the lowest number, but I'm the first one to boot up. So there's no any other who have shown up that they have higher number, unless everybody now is up and active. That's when now we'll be exchanging packets, not readjust. You're being informed you're not the one. Huh? I'm the one, I'm here. Even though I was the last one to be booted up, but now I'm up. The rest take you up places. Okay, so I become the DR. So that's how we can have all this. So with the failure, DR failure and recovery, after the DR is selected, it remains the DR until one of the following events occurs. You have failed. So had we a problem with that device? Okay, you're not being seen on the network. You have failed. Or the OSPF process of the DR failed or is stopped. Or the multi-access interface on the DR fails or is shut down. Those are the only scenarios you can have all this DR. But when you fail, then BDR automatically will be promoted to DR. That's what we said. And it is the case even if another DR or DR other is there with the highest value. We'll not consider that one because you are others, even though with the only possibility for you is to become a BDR, not BR. Because we are considering the first two, which were already elected. Even though another router was added with the highest interface ID or with the highest router ID, 555, maybe router 5. But no, that's not a must. We'll only consider the BDR to be promoted. Then because you are among the others, but with the highest, you become the now BDR. That's the only favor they can do for you there. So how do you set these priority values? Yes, you can set them. You can set them using the command IP OSPF priority are there. But on the interfaces, they can be set on the interfaces. You can see interface gigabit Ethernet 0000, then IP OSPF 255. So you are the highest. That's the meaning of this. Okay. That's the meaning of this. You are always the highest. That's the highest value data that we have. Metric. OSPF uses the cost as its metric. Take note of that. OSPF uses the cost as its metric to determine the best path for any packets. So which one is the best path for you? So I'll use this metric. Just like you see, we used to have the RIP. The RIP. RIP will consider the path with the least number of routers on the way. Path A, path B, path C. Path A, path B, path C. The path with the least routers will be the preferred path. But for the OSPF, we check the cost. So a lower cost indicates a better path. That's the point. Okay. And we have the default one. Huh? You know, usually these interfaces that we have, by default, they can work out the cost. The cost. So therefore, a higher bandwidth indicates a lower cost. The formula used to calculate the cost is this. It's a reference bandwidth divided by the interface bandwidth. And the reference bandwidth is always 100 million here. Okay. Divided by now with the interface bandwidth that has been given to get that cost, to get the cost there. But still, you can manually adjust the cost by setting the cost. If you don't want to use the default numbers that are there, you can adjust your own cost. You can adjust your own cost. So if you look at all these interfaces, right, from 10 gigabit Ethernet all the way to the Ethernet here, so you can just compute the reference bandwidth divided by the interface bandwidth that is given for each to get the cost. Okay, to get the cost. So same cost due to reference bandwidth here. Okay, so all of them will be 1, 1, 1, 1 there, as they have indicated. But that's not a problem. As we have said, you can always adjust and come up with a cost using auto cost reference bandwidth. Okay, auto cost reference bandwidth to adjust that cost. So this command must be configured on every router in the OSPF domain. In the OSPF domain. Okay, so that's the point there. Another option is to change the cost on one specific interface using the command IP OSPF cost. Then you specify the cost that you want. Okay, you specify the cost that you want. That's another way you can also work it. You can also work it out. You can also work it out there. Okay, so you can always adjust those costs. So if you look at this, for example, accumulates costs. So how the packets will be moving from R1 to R2, you can see cost is 10 in each. Okay, so which one is the best path? Which one is the best path? So you just need to check and to add, depending on how you want to move. Okay, I want to go all the way to R3 LAN from R1. So you can see the LAN for each is cost 1. Loopback 0 here, cost 1. Up here, cost 1. But in between is 10, 10, 10, as you can see. Okay. So in that case, if I want to move from R1 LAN to R3 LAN, which route am I going to take? Is it R1, R2, R3? Or is it R1, R3? Because that's what I'll be able to check. Because the cost must be least. The one that will give you the highest cost, I'll not trust it. That's the point or the term. I will not trust anything that has the highest cost, the path with the highest cost. I'll only consider the one with the lowest cost. Because here we'll have to add R1, R2, 10, R2, R3, 10, that's already 20. You have not even added the loop back. Okay. Yes, so you end up moving from R1 to R3. Okay, because you see, it will be this one. Okay, yeah, correct. Correct. Cost 1 plus 10, huh? Okay, plus this cost. So for me to get, see, for me to get here, you see, I'm talking of 11 or 12 on the higher side, unlike 20 something. Okay, so that's actually how it will work on it. So in that case, you can see, for example, the total cost for R1 to reach that network. Where's that network of 10, 10, 20 up here? 10, 10, 20 from here. Okay, network is 11, meaning you're getting here this 10 plus 1, 11. Okay, 11. The loopback default cost 11. You can verify this with the command show IP route. Okay, so that's what you'll always get. You see here, the cost is 11. Forget about 110. 110 is the default AD. OSPF has an AD of 110. OSPF has a default of 110 as its AD. Okay, static has 1 as its default AD. ERGRP, we have internal ERGRP which is 90 and external ERGRP which is 170. Okay, for the border gateway protocol, usually is it 20? So you just need to know the cost for each of these protocols. Huh? So it's always cost stroke metric, cost stroke metric. So if you see 1/0, so it's the AD and metric, 110/11, AD and AD is the distance. That is the metric. Huh? So please take note of that. So distance is 110, metric is 11. Okay. So as we have said, you can adjust the cost on the interface the way they have done it here. The reasons to manually set the cost value include that admin may want to influence path selections because you have been using this path for so long, and today I just want to influence it so that you change to a different path. So the path that used to have the lower cost, I can adjust the cost to be higher. But now that route which we said was 11, huh? Okay, or route 1, route 3, for example, it was 10 and 1. So that 10 I can adjust it to something else, to 30. So that now it will force you, look at this. It will force you here. If you decide to adjust this to 30 between R1 and R3 to 30 instead of 10, then there's no way I'll make use of this route. I want to make this route to be undesirable. Maybe I want all the packets by all means to go through R2. Then now, to anywhere that you want to go is okay. I don't want to use the shortcut. Maybe that R2 is your what? Is your firewall integrated router. It's the firewall integrated router, and it's the one that link you with the public network. So meaning all the traffic are being filtered there before they get out of your network or get into your network. Because the central device and you have set with the firewall, okay, and the rest R2 and R3, I mean R1 and R3 has not been set to the firewall. Okay, so I'll adjust the cost between R1 and R3 so that all the packets will make use of R1, R2, and R3, but using the shorter cost. Because I've not adjusted the 10 in between. So it can be 21 instead of 30 something down here. That's how you can always adjust your network in case you are doubting some devices. So Again here, resources to manually set the cost value include connections to equipment from other vendors who use different formula to calculate OSPF. Also can force you to adjust the cost. Okay, you have Huawei on the other side and the router device on the other side. So you can adjust the cost still. Okay, are there. So this is what we have. A test failover to backup route. Okay, so you can see the cost that has been set here. What happens if the link between R1, R2 goes down? You can simulate that by shutting down the interface G000 and verifying the routing table is updated to use R3 as the next stop router. So notice that R1 can now reach that network through R3 with a cost value of 50. Okay, because of those adjustments you are doing within your network. So you are free to adjust the network the way you want. As we finalize, I know I'll not be able to do labs today. Tomorrow, first thing, I will start with the lab. Today I'll not do the lab because it's a lot. It's very involving. So I need you guys to have time so that we do the lab together. In the same lab of static that we'll be doing, I'll not remove static because there are things that I want you to understand. If at all I have dynamic and static, what happens? You know, that's why I want us to do it tomorrow, those labs together, so that you get the concept completely. Meanwhile, as we finalize the LO packets intervals, you know, we have talked of the LO packets, very, very important. How do I know you are there? You are live and kicking. We are communicating. I'll send the LO packets to you. Okay? But now this time that I'm supposed to specify. Imagine someone is greeting you hello and you're not responding, or you are responding after 20 minutes. Okay, so there's a problem somewhere. So there's an interval that has been set, hello packet intervals. So these packets are transmitted again to multicast address 224005, just like the DR. Every 10 seconds, okay, they're being transmitted. So it's the default value on multi-access and point-to-point there. Okay, so, and again, if the interface has been set to passive, then you want to be able to receive the hello packets. And that, by the way, don't make a mistake of setting the passive between the interfaces that connect router 1 and router 2, router 2 and router 3. Don't do that mistake because it means we'll not be communicating. You'll not be receiving my updates. I will not be receiving your updates. That's the meaning of that. These passive interfaces are being set on the LAN, where the switch and the PCs, but not in between the routers. Take note of that. Take note of that. Apart from the interval, the hello interval, we have also the dead interval. The dead interval is the period that the router waits to receive hello packet before declaring the neighbor down. Odi hapa, no response. Odi hapa, umuta yuko. Dead intervals. Huh? You see, like 5 minutes I respond, umuta yuko. Dead intervals. Dead intervals. You see? So it will be clearing data because you're not responding. You're not even, I'm texting you. No, you're not responding back to me. So what do you expect? Okay. So let's give you 5 minutes. Kama ya respond umuta yuko. Dead interval. If the dead interval expires before the routers receive hello packets, OSPF remove that neighbor from its link state database. Toa kabisa kwa database yako yuko. Okay. Hapatikani. So, therefore, Cisco uses 4 times the hello intervals. Cisco normally use 4 times the hello intervals. So this is 40 seconds on multi-access and point-to-point. Okay, so what is the meaning of this? If the hello interval is 10, times 4, dead interval is 40. Please take note of that for the sake of certificate exams as well. Okay. If the LO interval is 10, dead interval will be 40. If the LO interval is 5, dead interval is 40. Why am I bringing this? Routers A and B cannot form adjacencies. One of the requirements for the routers to form adjacencies is that there must be a matching LO and dead interval. LO interval is 5 on router 1, should be 5 on router 2. Dead interval should be 20 on router 1, should be 20 on router 2. Therefore, we are forming adjacencies, the neighbors. If there's a mismatch, we cannot form the adjacency. The same thing in the exam. This router and this router cannot form adjacency. Based on the output given, can you highlight the reason why they're not forming adjacencies? Mismatch of those LO and dead intervals usually is the cause of the problem. Take note of that as well. Okay, so that is to say, look at here. That is to say, LO is 10, dead is 40. So expect the same on R2 to be 10 and 40. So you'll be given the two output against each other, R1 and R2, with the same output. Then you are being told to analyze, then give reason why they're not forming adjacencies. Okay, so take note of that as well. Okay, and there. Show IP OSPF neighbors. Okay, just to confirm that everything is working. So there's that countdown. You see, I've talked of dead interval. No? Dead interval. So if it's 40 seconds, as we have said, so there'll be countdown. Countdown. When it gets to 0 before receiving any response, umutayuko. So these are countdown. Okay. LO 40, 39, 38, until it get to 0. No response, ayuko. Okay, remove it from your database. It's not responding. Maybe there's a problem with that. So this is how you can set the interval. IP OSPF LO interval. Okay, IP OSPF dead interval. You can adjust instead of using the default one, because Cisco products uses the default one 4 times. Okay, the LO interval. So you can adjust and have your own. Okay, you can manually. OSPF LO and dead intervals can be modified manually. So you can adjust. Feel free if you want to adjust there, as you can see. Okay, IP OSPF LO interval 5, dead is 20. Dead is 20. So you're just doing it in each and every router that we have there. Then finally, when it comes to default route propagation, remember what we said. You can set a default route, like the way we did yesterday, or not yesterday, last week. Okay, IP route, then we set the default route. So we did it, if you remember, we did it on R1, but we want the same route to appear on R2 and R3. There's no need of configuring it on R2 and R3. Instead, you can propagate it using which command? Default information originate. It will propagate these routes to other routers that you have on the network. All the routers that are on your network will receive the same default route. That's the beauty of now setting up your network with dynamic routing protocols. Okay, but when configuring static route, you cannot configure it using, when configuring default route, you cannot configure it using dynamic route. It has to be static route, IP route, then you set it. That's the only way you can configure that. Okay. Now, when you set that one, you'll be able to see that, yes, the route is a default candidate route, as you can see here. But now, because you had set it on R1, now on R2, it will appear as an external route, Notice that the root source on R1 is OSPF asterisk E2, signifying that it was learned using the OSPF. The asterisk identify is a good candidate for the default route. The E2 designation identify that it's an external route. So E1, E2, for those who are doing in future, if you'll be doing CCNP, you get more about E1 and E2. They have been discussed there. Okay. For now, just understand the external bit of it. But there we have it. We have it in CCNP. So that's what also I'm teaching. All the details are covered in CCNP as well. So, of course, with the verification, you just verify your network using various commands, show IP interface brief, show IP OSPF neighbor, protocols, show IP OSPF, show IP OSPF interface, okay, are there. Just to verify that everything that you have configured is fully set and is working. Finally, as we leave, now I talked of adjacency. I want to emphasize that because I know they are common in the exams. Two routers may not form an OSPF adjacencies if the following occurs. The first one is very obvious. The subnet mask do not match, causing the routers to be on separate networks. So mismatch of the networks. Mismatch of the networks. The OSPF LO ordered timers do not match. This is what I was talking about. Okay. Then the network types, OSPF network types. Ingine ni network types broadcast. Another one, network types point to point. Are you getting the two? There's nowhere they can form adjacency. Then it's a missing or incorrect OSPF network command. So these are the possibilities. Okay. But they will not ask you these direct questions. As I've told you, always they'll be in form of applications the way I've been describing them for you. Okay. Don't expect them wakuulize vitu kama hizi. They'll be in form of applications, more so form of the exhibit. So it is you to analyze and correct the problems are there. Okay. So that's the point there. Then finally, the protocols that have been used here is OSPF, show IP protocols. You'll be able to see that it is an OSPF that has been used here with the process ID 10, of course, with the router ID being set. And you can see also, other interfaces that also are configured with the OSPF are there. So that's the most important bit, okay, that they're trying to demonstrate for us here. Okay, as you can see, everything that we have, just to confirm that, it's the same thing. Those 4 things that you have talked about, 4 or 5, is what they're trying to verify. This one here, 1, 2, 3, 4, is what they're trying to verify. What is this that I'm not able to form the adjacencies? So that's the output that they're trying to give. Okay, are there? Just to confirm that why the adjacency is not being formed, or why the adjacency might be formed are there. So based on these outputs that we have here. Okay, so guys, that's all. That's all for today. Sorry, I know I've taken much of your time, but I think we are still within the time because we have to stop at, is it 7:30 or 7? Okay. Okay, so I will not take you through the labs. Allow me to skip that one for today, but tomorrow, first thing, it's lab for this topic that we have covered today. We'll start with the labs. And which lab? This lab here. I'll use the same topology. I'll use the same topology to configure OSPF so that we understand. It's still having the, if you ping 102.16.2.10, if you ping command prompt ping 192.168.2.10. Of course, still there'll be communication, because I saved everything. You can see this communication. Okay, so this is also what we expect when OSPF is configured. But as I've said, I don't want to remove this. I'll configure the OSPF as well. Then we check. Okay, and compare. You will see one will be floating until the other one is removed. When you remove it, automatically the other one comes in there. So for tendency of the networks, those are things that we usually consider, so that in case of any problem, we are good to go. So let's start from the labs here tomorrow. Okay. Thank you guys for your time. How can you access the recordings? I usually post them in the group. If you're in the group, then all the recordings are in the group, are there. Yep, so the recordings are in the group. Or you're not in the group, then I think we'll have to contact Kevin. Yeah, I think we'll have to contact Kevin. Kevin will be able to sort you out. That's okay. Sawa Kimutai. Okay, guys, let me now release you. Let's meet tomorrow for another session. Enjoy the rest of your evening. I'll post the recordings the moment they're available. They'll be ready.